So what we're going to do today is put ourselves in the shoes of a developer who starting his journey with Kubernetes and developing application for Kubernetes. So who is or considers himself or herself as a developer? Oh, that's good. So yeah, definitely, hopefully this session is for you. I won't introduce myself anymore because we only have 30 minutes. We're probably about 95% demo, but I just want to introduce the tools first. What we're going to do with a sample application I've built, hopefully should be a fun one. And we're going to navigate through different tools, different steps in the coding lifecycle and see what we can do. We're going to be focusing on the inner loop development. For those who are not familiar, the inner loop development is essentially what you do before committing your code to an enterprise, version control system. Or, I mean, the trigger is a bit, it's a bit blurred where you may commit to your own repo first or to a test repo, and you may have your own pipelines, or the pipelines you manage within this particular repo, and then you will do a PR into the main repository, the enterprise repository, where you have all the enterprise pipelines running. So today we're going to focus on really your local environment before committing, or eventually committing and doing some tests yourself with local or potentially remote Kubernetes cluster. So the different tools, let's start with the different lifecycle stages. So we have essentially code, we have debug, we have build, we have deployed, and we have run, right? So for coding, so I don't know if you already feel this, you had this feeling where your laptop is broken and you need to build it again, restoring from your image. Can be annoying, can take time. So today there's a lot of different tools that essentially build a repeatable, consistent, and reusable environment, developer environment where you can essentially work remotely. Things like remote containers, Git pods, all that. So this is if you're really struggling, with your laptop, if you don't want to be annoyed when rebuilding an image, maybe that's the best way to go. Have everything into a container. Your dev environment then becomes that container a lot easier to reproduce. Things that you need to consider when you're starting to code, especially around Kubernetes, you start to use config map, you start to use API keys, all those kind of things. So you don't want to hard code your environment variable when you migrate to Kubernetes. There are native constructs like config map, secrets you should use. And of course, if you commit a secret to your repository, to Git, then you're going to be in trouble, right? Because secrets are not really secret. I think everyone knows that. It's just base64 encoded, and encoding is not really encrypting. So Git leaks is a pre-commit plugin. So pre-commit is using these Git hooks. There are hundreds of plugins you can use. Git leaks will detect a pattern in what you commit to Git in terms of sensitive data, and will just deny the commits if there is sensitive data. Another thing to take into consideration is the patterns when you're developing microservices for Kubernetes. So I recommend the 12-factor app website. If you don't know it, it's really a must. It's going to teach you the different patterns you really should apply when starting by designing an application for Kubernetes and the different microservices. Then the build stage. So probably, most of developers are familiar with local Docker Compose. If you have external services, external dependencies, very easy to deploy, Kafka, MongoDB, all those kind of external tools with Docker Compose. Then if you need to bring a bit more automation, once you get closer to production, then you have Makefile. Probably everyone knows this, especially the older or the oldest of us, because it's been there for a couple of decades already. More modern, I would say Earthly with Earthfile. I would suggest this one in replacement to Makefile. They describe themselves as if Dockerfile and Makefile had a baby, which is, it's quite accurate in the sense that in Earthfile, every step of what you're doing is going to be run in a container. So kind of be also like CI step. Everything is run independently in different containers. So there's no such thing as, it worked locally on my machine, but it did not run in the pipeline. Everything is in container, so it's very consistent. Then once you start deploying into your Kubernetes cluster, your local cluster, of course, you start with raw Kubernetes manifest for simple things. But as you move to more complex, more convoluted application, you may want to use Kustomize or Helm. Kustomize is more like if you have, prod, dev environment, very simple things to change with some concept of overlays. If you want more complex templatization capabilities, enabling, disabling component, customizing inputs, then Helm, which is a package manager with a lot of templatization capabilities, is what you want to use. There's also Q, which is like the new kids on the block. It's a data validation language that's can ingest your existing Kubernetes manifest into Q-specific syntax and will reduce 75% of the boilerplate, plus do all the data validation in YAML, which can be very useful. So also something to consider. Deploying, so you have your application ready, the code is there, you want to run it deploy it into your test Kubernetes cluster. A couple of options here locally. Minikube, Kind, K3D are all valid options. Today we're going to use Minikube in the demo. 7 minutes, so I have to go faster. So then the full dev experience plus automation, covering things like synchronization between what you have locally and the remote container in Kubernetes, so that you can change code live without rebuilding the image. You can hook it into things like Delve, like remote debuggers. All of that can be embedded into single tools, such as DevSpace, Scaffold, or Till. Today we're going to be using DevSpace. You can run pipeline. Essentially, what I like to consider DevSpace is, when you start with Docker, single container, then you move to Docker Compose, multiple containers. You want something easy to deploy your microservices with all the dependencies. As I said, if you have databases and things like that, messaging, queuing, all of that. If you want to move to Kubernetes, there's no real solution out of the box. Part of Kubernetes, like Docker, there's no Kubernetes Compose, right? Of course, there is Kustomize, Helm charts, all of that. But when you start, you don't necessarily want to learn those tools. You want something a bit more simple. Then DevSpace is your friend. So DevSpace is also going to build a Helm chart for you via another project from Loft. It's going to build all the pipeline for you. It's going to replace your application container with a dev-specific container so that you can compile your code and hook the dev debugger. All of that is part of that tool. And you can also include other dependencies like databases, like with Docker Compose. So I really recommend those kind of tools when you start being a bit more serious in terms of testing locally the whole application stack. Then you also have to think about security. When you go more closer to the enterprise pipeline and commit into the enterprise, you do your PR into your company repo. So we talked about secret management before and environment variable, API key, all those kind of things. Easy way, easy path, you can use SOPs, which allow you to commit encrypted file into Git using a PGP key, and then you can distribute that the private key into a KMS server or to people of trust. Then they can decrypt the different secrets, or you can use GitOps with Argo CD. And Argo CD, if you give it the PGP key, will be able to decrypt the secret and use that secret as part of your GitOps pipeline. Right? So this is another solution. More complex, you have Vault, Trousseau as a KMS, container tools for linting your, I don't know if you're using Terraform or any sort of policy as code. Checkoff will help you do that with best practices. Dive to inspect your container images in detail. Also have some CI capabilities. If the image is too big, it's going to fail the build. Quite interesting as well. And then we go into container image signature. You don't want, especially in production, to deploy containers that are not signed. So you want to sign first with cosign, notary, things like that. And then use policy as code like Kyverno to prevent non-signed image to be deployed in your cluster. Then, of course, you have all the SBOM, for dependency tracking in terms of all your containers, then that you can feed into some tool to do vulnerability scanning against databases. So probably today what we're going to be using, it's Sift for the SBOM part, and then in conjunction with Gripe, that will take the SBOM and check against the vulnerability database to tell you if there are any issues. So as I said, deploy signed images only. Today we're not going to use like multi-stage build, but it's really a best practice. Multi-stage build for your container. First part of the build, first stage, you compile your code. Second stage, you start with a distroless container and just copy the binary, typically the best practice. And Kyverno is basically using an admission controller to prevent the non-side images to be deployed into your cluster. But yeah, don't build your own admission controller. Kyverno can do this for you natively. Okay, so the app we're going to be using today, it's a dad jokes generator composed of 5 microservices. So it's, overkill on purpose, just for demo. And we're going to turn it into a Chuck Norris joke generator live, or a German dad joke generator in German. We can also do this. So the architecture is that one. So the part I recoded was the joke server and joke worker. So the user requests a joke from the joke server. It goes to a NATS message queuing. The joke worker will pick up the message containing the request of the joke. Then the joke worker will connect to OpenAI using the DaVinci 3 model to generate a that joke, put it in the Redis cache, as well as in a MongoDB database. When there is enough entry in the Mongo database, then it's going to retrieve some jokes from the Redis cache. Doesn't necessarily make sense, but it's just for demo purposes, right? So let's. So I didn't sacrifice a goat today, so she's happy actually. She's crying, but she's very happy. I didn't sacrifice her, which means that anything can go wrong. I tested yesterday, and of course it was working. Today, I'm not sure. So this is my code repository. We're going to start. So probably I won't be able to, in like 18 minutes, to show you everything I've mentioned. So I'm going to cherry pick some of the functions like as I go by feeling. Normally it's like it's a 2-hour workshop, but let's go a bit into first the structure here. So this is my real code, typical Go project. I've got the CMD with the joke server, joke worker directory with the code, the Docker file. Very simple and bad Docker file because it's not multi-stage. I'm just, using the Golang container, copying the dependency, downloading them, copy the main.go, and then just compile it and expose the port. Basically it. For the joke worker, kind of same thing, very simple, compiling, copying files, nothing very special. I've got internal, so which is like all my constant variable, my API key, I'm gonna pull from my environment variable, and I've got all the code itself to generate the joke. And here you can see like the prompt for the DaVinci model, so tell me a dad joke. We're gonna change it into tell me a Chuck Norris joke, as easy as that, all right? So. And then all the logic to do in caching and putting in Mongo database. So nothing very too complicated there. And then the part we're going to be focusing on is the deploy part, right? So essentially the dev space section. And you can see here I've already encrypted my OpenAI API key using SOPs, which gives you this file, right? So you cannot do anything with that file if you commit to a repo. You will need the PGP key, private key, to decrypt it locally, like if you want to distribute to your colleagues or put it in the KMS. Or as I said, use Argo CD with KSOPs, which is the Kubernetes version for that. That it itself will have the key and will be able to use that to deploy the application. So let's go a bit more into dev space. So dev space, as I was saying, really increases your productivity as a developer by 300%, which may be, it's good, right? You can do something else and make people think you are working, and you can enjoy yourself. So essentially, it's really helpful to do multiple things. Like first, it helps create. Okay, good. It helps you create pipelines natively by using macros. So you can create arbitrary number of pipelines like dev, deploy, and then run some macros that are part of the dev space, of dev space out of the box. So for example, here in the dev pipeline, what I want to do, so dev means that I'm going to run dev space dev. If I want to run the deploy pipeline, dev space deploy, etc., etc. So for the dev part, I'm going to run all the dependencies and ensure pull secrets, so all the images. Build images. Usually dev, you don't necessarily want to do it, but for the demo, I'm going to be doing it. It detects if you're using like a Minikube or something like that. It's going to be using the Minikube Docker socket to build the images and not push. If it's local, it's not going to push it into your upstream repo. If it's a remote cluster, it's going to push it to your upstream repo. Then it's going to be creating and deploying all your Kubernetes components. So here we're going to deploy first in order a MongoDB operator, a Redis operator. Then we're going to deploy NATS, the joke server, the joke worker, and all the custom resources. So mainly the Redis database and the MongoDB database. So of course we have the operator first to make MongoDB and Redis first-class citizen in Kubernetes first, and then the operator will ingest the manifest to deploy the databases. So we need to do that in a second step. And then we're going to start the dev process. And the dev process, essentially what it's going to do, where is it, dev? Deployment, images, deploy, bit down, dev. So it's going to select a container or in your application stack and replace it with an image potentially. So I didn't replace the image here, but by default, it will replace it with a dev space image that has multiple software, lot of software embedded. I mentioned Dell for debugging. It's not going to compile the code, so you will have to compile it inside the container and do your testing. So for today, the only thing I want to show you is some sort of automation you can do. Like every time there is a modification in this path locally on my machine, is going to restart the container and can do some action. So here what I want to do is, as I change from create a dad joke to create a Chuck Norris joke, I want dev space to redeploy my container, restart my container and recompile the code with the change, right? Which means that I don't have anything to do other than save my new code, and automatically I will have the new code running in the container, right? That's the idea. So on upload, restart container, and I want to run that particular command. Then you can also have hooks depending on where you are in the dev space stage. If you want to, when you do dev space purge, to delete all the components. I'm using some stateful set here, so I'm deleting PVCs. There's a lot of customization you have to do there, but I didn't really build any Kubernetes manifest. And actually, a bit, even better, when I have a raw Kubernetes manifest, what DevSpace can do is use another project from Loft, which is called component chart, and convert your manifest into a Helm chart and replace some of the value within this, like all the environment variable, which is great. And then it's also support. So in the custom resources directory, I have like some Kubernetes manifest, copy paste from the operator to create my database, Redis, all that. I just copy pasted that. And it can use raw manifests, but it also supports customize, right? So you can create overlays. So you have all the tools I've mentioned embedded into DevSpace in a single file. So of course that file can evolve over time, and you can have more and more, the file is going to be growing over time for sure. But essentially, you just have one file to maintain that will be valid for building your images in the image section. You define, where the Docker file. The deployment, as I said, you can use Helm, existing Helm repository, or using the component chart. So it's really like a Docker compose, a bit more data there because, of course, Kubernetes is more complicated than Docker. But essentially, whether it's for testing, coding, changing your code, deploying, everything is in one file, right? So it's really great. Okay, then I've got here the sign image cluster policy, which is again copy-paste from ContainerDays, where I only want to check against all the images coming from my repo and use a rule that says if I want to have a pod of deployment out of that manifest, I want to use an attester using the record database. So I don't know if anyone is familiar with Sigstore, record, all that, but it's basically you sign your image, it's added into a transparency log into record, and then it's going to be used to validate the image signature. And this is what ContainerDays is going to be doing here. So 9-10 minutes. So let's try. What I'm going to do, I'm going to show you maybe the sync part, which is probably the coolest one. So first, let's deploy. So hopefully, it's big enough for everyone. Let's check here. Can you see that? Yeah. So this is my local Minikube environment. This is my dev namespace. I have nothing for the moment. So let's start by going into dev space directory. Here I've got my devspace.yaml, so I can start with dev space dev. I specify the namespace, so it's going to run the dev crossfinger. Right, guys? Okay, working. So it's deploying everything, right? The Helm chart, the custom resources, everything I wanted. It's deploying my code, tagging the image, and you're going to see it's exposing the application already on port 8080, syncing my file. Making the file ready for sync so that if I modify now, it should be working. So error, it's normal at the moment because if you see here, it's just like, NATS is not ready yet, so let's wait a little bit. So you can see I have my Redis operator, my NATS message queuing system, Redis MongoDB is there. I've got my 2 container crash loop backup. I'm not too worried at the moment because still waiting for NATS. You see like dash dev space, which means that it's actually replaced the container image with the same image, actually, but it's just to show you that, it's the process. Once you have flagged this image for image selector, select the container and go into the dev section of that particular image and say, okay, now it's ready. If I change something, it's going to restart the container, compile the code, and run the automation I've specified. So here running, no error message again. Let's try to generate some jokes. Crossfinger, I'm depending on the internet here. So, okay. Yes, it's working. Woo. Okay, so dad jokes, right? So it's not supposed to be sort of funny. I don't know. Okay. Anyway, then I'm gonna go locally, right? So this is running I've got my container running in my local Kubernetes cluster with Minikube. I'm gonna go into the internal. Where is it? Internal. Let me make it a bit smaller here. Internal. joke.go. Here you go. I'm gonna look for, sorry, not here, for dad. Chuck Norris, Chuck. Oops, not Chick. That would be other kind of jokes. Okay, before saving, I'm just gonna go into here, the log of my container here. So, okay, just wait now. Save. Okay, synchronizing. It's kill. So kill the container, restarting the container. So now, just by doing this, if I just the code again, crossfinger, Chuck Norris should come in action. Yeah, thank you. A couple of other. I love the one when you said that Chuck Norris can divide by 0. No? Okay, so yeah, it worked. So that was for, what can I show you? Again, maybe like the signature part. Oh no, the ContainerDays. Let's 5-6 minutes. So okay, we still have some time there. Maybe. Okay, let's try to. So ContainerDays. I'm going into the policies directory, which is a bit about this. So the policies, I've got my, so Kubernetes apply this policy. Okay, policy created, which is good. Then we're gonna check some. Here I'm using. I don't know if anyone. I mean, probably a lot of you already know this tool, K9S. If you at any part of your Kubernetes learning journey, if you doing like a CNCF certification, Kubernetes certification, you don't want to be using this. But after that, when you don't care about the certification, you don't have to use kubectl for most, let's say 80% of the time. You can just use K9S. You know, you can port forwarding, deploy things, apply manifest, logs. You know, just check your logs. It's amazing. CRDs, cluster policies here. The YAML, yeah, it's faster then. Right. So here, this is basically what I showed you before. All the images there, only the signed ones are allowed. Oops, pods, okay, pods view. So now I should have, I'm gonna run an image that is unsigned, and I should get an error message. Yeah, so you can see here like the admission controller has denied my deployment, my pod actually, which is just Kubernetes run this particular image, because for the reason that I didn't get any signature. So if I go now into the cluster for audit logs, I should see in my CRDs, not DRS. CRDs, come on, CRDs. Admission report, not this one, maybe. Yeah, sometimes admission report is just for the image that passed. So let me show you an image that's, okay, this one should be. Yeah, so this one is signed, and you can use also cosign verify. So let's sign an image first. So you can do this. There's two types of signature. There's like one you can sign with a key, such as a PGP key, and the second option is to have a keyless signature using Google OIDC, which is quite convenient. So you're just logging here with your Google account or Gmail. Corresponding to Gmail email, and yeah, it's basically it. Once it's signed, then you're good to go. So it's pretty fast. There's no real reason not to do it. Those things, it took me less than 5 minutes to apply the policy, sign my images. So it should be part of your practice to do this all the time, right? And you can do cosign verify. Is it? No, not sign. Cosign verify. Cosign. Verify, sorry. Maybe not this one. I don't know if this one is signed. No, let me use another one. Cosign, verify. Here, this one against Google with the OIDC, and this one should be fine. It's going to tell you basically, it's going to print the stamp, Yeah, so this one you can verify is signed. Just quickly, 2 minutes, sift and gripe. So sift to generate the SBOM, depending on a specific image. So the idea is loading the image, and what it's going to do is print, -o table here is going to print on the screen all the dependencies. And then you can also generate a JSON file out of that you can later feed into gripe as an SBOM. So if I go back, so it's going to tell you all the dependency. I've got a lot of them because I didn't use multi-stage build with a distroless image. If I go back here, and then gripe, here should be fine. All right, so I've got all those dependencies, and you can see the fix, if there is fix, the version, so it's going to tell you what you need to update, the CV reference, and the type, of priority if you should pay attention to it or not. It doesn't solve it for you, right? That's the main point here. So there is some manual work, but if you don't want to worry too much, minimize the footprint of, like the attack surface. Just use multi-stage build and a distroless image, right? So that's basically it for the demo. I'm so happy it worked flawless. Maybe it was because that was my birthday yesterday. That's my present. Thank you. Okay. So the key takeaways for today. so we've seen that developing cloud-native application is a lot easier than before, like 6 years ago when we started with Kubernetes. The developer experience, I really feel, is fundamental for Kubernetes adoption because ultimately we are running app in Kubernetes and developers are developing apps, right? But at the same time, you don't want to overkill it and just drown your developers in the sea of the CNCF landscape. Even for us, sometimes it's like, what the heck is all of that? So start small and then build on top of that, but still, adhere to basic best practices I've mentioned today. Use remote container for coding, make it secure, build slim images, use like a tool that will help you the same way Docker Compose help you. And of course, the environment you build, share it with your colleagues because sharing is obviously caring. So is there a simpler way as a developer? This is like the marketing hooking, right? So I work for Spectral Cloud, and actually we made things a lot easier for developer to deploy and test their code into Kubernetes by using also another loft technology called vCluster, building virtual cluster for every developer, which is reducing, like the footprint again in terms of security, the attack surface, because every developer can have his virtual cluster, and then we have a nice UI, same sort of concept of desk space where you can deploy container Helm chart from just from the UI, and also like all the dependencies, MongoDB, manage all your environment variable and do all of that. And that's basically it. So the tools we have used today, just so that you remember them again. So Git, git list, pre-commit security before committing to GitHub. Makefile, but to be honest, try Earthly. I didn't have time to show it today, but if you're going into DevOps Morocco, I have a 2-hour workshop based on that particular set of tools. So DevSpace, pre-commit, or if you want to do that lab, you can send me an email. I've got an Instruct lab with all the instruction to do exactly what I've mentioned today. So you can find me on LinkedIn or Twitter, whatever. I'll give you the link. Sift, Gripe, Kyverno, and ContainerDays. So yeah. And yeah, that's pretty much it. And this is me done on almost time. Thank you.
Excellent. So questions are open if you wanna ask questions or put it in a dad joke yourself, but you have to also include the solution.
Okay, why would anybody not use DevSpace then? Is it Leanne who has the question? Someone from Loft.
I don't know.
No, there's no. Why would anybody not use DevSpace then? I see no reason. I mean, DevSpace, or as I said, there's other tools. There are commercial tools like Tilt. There is DevSpace. There is Scaffold. Pick the one you like. But typically, I would say there is a bit of a learning curve still. So you have to go through the documentation. So if you only have one Kubernetes manifest to test one container or one deployment, yeah, it's a bit overkill. But other than that, there's no real reason not to do it when you grow.
All right. Any more questions, or can you serve as one dad joke, maybe?
Again? Okay.
Or maybe two. I mean, you have to also deliver them with,
Oh, but yeah, we can't see the screen now. But it's still Chuck Norris, right? Oh, let me. Oh, but now, yeah, it's not exposed anymore. So
you don't remember.
It's broken.
You don't remember them by heart?
Oh,
like
no, like. Okay, Chuck Norris doesn't dial the wrong number. You answer the wrong phone.
Okay, one more.
Chuck Norris can slam a revolving door.
I actually like that one very much. All right. Well, thank you so much for your talk and for all of the jokes in the laughs. We're starting here again at 10 to. Oh, that's a Dutch way of saying it. 12:20. That's when we start again.
Thank you, guys.
Thank you.